Technology has quickly taken over the world and changed the way we live. Take the example of robots. Robots can do tasks much easier and more efficient than human beings. Yes dear, you heard me right. So that they can be employed even in unstable and hazardous environments. Amazon now has 200,000 robots working in its warehouses. But have you ever wondered how these robots even move? Especially their arms? Well, at every joint of a robot to activate movements and give the robot arm its precise angle, there is a component. So dear, listen carefully. We are going to learn about a new component. It's called a servo motor. Do you have any idea what a servo motor is? Don't worry dear, we are going to design an interesting project using servo motor. So dear, now let's understand what a servo motor is. A servo motor is an electric motor that can be used to rotate an object at a specific angle between 0 to 180 degrees. You might be wondering, how is it different from the other motors? The other motors, when turned on, can be used to rotate either in clockwise or anti-clockwise direction without any specific angle. So dear, in the previous session, we learned to make the LEDs blink and also created amazing patterns for the LEDs using text coding. In today's session, we are going to design a circuit using potentiometer, Arduino and servo motor, and we will be using text coding. Excited? Well, let's begin. In the component library, search for Arduino. Drag and place it on the workspace. Now let's add the new component. So search for a micro servo in the component library. Here it is. Let's drag and drop it to the workspace. And then rotate it and move a little towards the left. As you can see, servo motor has 3 terminals. These are signal, power and ground pins. We know that to make any electric device work, we need to power it. The power and ground pins are used to power up the servo motor. To the signal pin of the servo motor, the instructions at which angle of the servo motor rotates can be given. Now let's start the connections. Change the Y color to red and connect the 5V pin of the Arduino to the power pin of the servo motor. Change the Y color to black and connect the ground pin of the Arduino to the ground pin of the servo motor. Then change the Y color to green and connect the digital pin D3 to the signal pin of the servo motor. Now let's do coding to turn on the servo motor. Click on Code. You can see some codes are present here by default. Just drag them to the left to delete, as we don't require them. Then adjust the connection and zoom out to make it a side to make space for the code space. Drag the code space left. Then from the output section, drag and drop the rotate servo on pin block. The digital pin D3 is connected to the signal pin of the servo motor. So click on the drop down arrow and change the pin number to 3. Here we can also select the angle at which the servo motor rotates. First, let's type 90 degrees and see how the servo rotates. Click on Start Simulation and yes, you can see that the servo rotates by 90 degrees. Then click on Stop Simulation. Now let's try changing the angle to 180 degree and click on Start Simulation. You can see that the servo rotates by 180 degrees. Stop the simulation. But what if you want to rotate the servo to 180 and 90 degrees? Go to Control and select Wait 1 sec block and place it here. Now duplicate the entire code and place it below. Let's change the angle to 90 degree. Click on Start Simulation. And yes, you can see that first the servo rotates by 180 degrees and then rotates to 90 degrees. And after delay, it repeats again. Now click on the code button to hide the code space and click Stop Simulation. Now I hope you understood the working of a servo by adjusting the angle at which the servo rotates. Now let's add another component to this circuit. Search for a potentiometer in the component library and then drag and drop it to the workspace. We can see how to use a potentiometer to control the rotation of the servo. The potentiometer has 3 terminals, right? Do you know the pins? Yes, it's terminal 1, wiper and terminal 2. In a potentiometer, there is a resistive track which is connected between terminals 1 and terminal 2. The wiper terminal will be moving along the resistance track while we rotate the knob. So the value of resistance can be increased or decreased by turning the wiper knob. Just move the potentiometer close to the servo motor. Now let's start the connections. Change the Y color to red and connect the 5V pin to the terminal 1 of the potentiometer. Then adjust the wire. Change the Y color to black and connect the ground pin to the terminal 2 of the potentiometer. Then adjust the wire. We know that a potentiometer is used to provide a variable resistance. So we can change its resistance value and give it as an input to the Arduino. Change the Y color to blue and connect the analog pin A0 to the wiper terminal of the potentiometer. Now adjust the wire connections to make it neat. Do you remember why we use analog pins here? It's because the value of resistance can be continuously varied and it is not constant. Now dear, let's do coding. Click on Codes and move the existing blocks to the left to remove them. Let's first create a variable. Click on Variables and select Create Variable. Let's type the new variable name as value and then click OK. Then drag and drop Set Value to block to the coding space. Go to Input and select Read Analog Pin block and place it on the Set Value to block. This block means that the value in the analog pin will be saved in the variable value. To see the changes in value, we can place a serial monitor here. So go to Output and drag and drop Print to Serial Monitor block. Then go to the variable and place the value block on the Print to Serial Monitor block. Now the serial monitor will print data inside variable value. Let's see how to adjust the resistance of a potentiometer to control the rotation of the servo. For that, go to Control and select If block. Then place it in the coding space. Then click on Math and drag and drop the relational operator block on the If block. Go to Variables and then drag and drop the value block on the left side of the relational operator block. And on the right side, set the value to 500. So if the value is less than 500, then the servo should rotate by 0 degrees. For that, go to Output, drag and drop the Rotate Servo on pin block on the If block and set pin to 3. And let the angle to be 0 degree itself. Now let's duplicate the If block and place it below. Click on the drop-down arrow in the relational operator block and change it to greater than. So if the value is greater than 500, then the servo should rotate by 180 degrees. Change the angle value to 180 degree. Click on Start Simulation and click Serial Monitor. You can see that the servo rotates by 180 degrees slowly as we rotate the potentiometer. The value displayed on the serial monitor is 982, which is greater than 500. As we change the value of potentiometer to a value lesser than 500, the servo rotates to 0 degrees. Try once again. Change potentiometer. When value becomes greater than 500, servo turns to 180 degree. When it becomes below 500, servo turns back to 0 degree. Now let's stop the simulation. Now I hope you understood how the servo rotates according to the variable resistance of a potentiometer. We have done our coding using block coding, right? Let's see how to do the same using text coding. We know how to change blocks to text from our previous session, so we are not showing that again. Let's move directly to text coding. So this is the space for us to do text coding. Here there are some text codes which we don't require. So erase these selected text codes by selecting and deleting. Now you can see two text codes and some brackets, right? Void setup and void loop. In void setup, we can define the analog and digital pins of the Arduino. That is, they can be set to input or output. And in void loop, the required function to be executed can be added. First, let's create a new variable. Type int value equal to 0. In line 1, this syntax means that value is a variable defined with a value 0. We know that a library is a place where there is a large collection of books, right? Similarly, programming also has a library. For the servo to work, we need to write codes to call the library of the servo. You might be confused, right? Let's make it clear with an example. If we type a keyword to rotate a servo, then in the library, there will be all the necessary codes to make a servo function. And these codes will be automatically set to the Arduino by default. So in order to call the library, type #include servo.h. Make sure the letter S in servo is in capital letters. We also have to set up a variable name for servo. So type servo1, then put a semicolon. S is in capital letters, where servo1 is the variable name for the servo motor. Go to void setup and type servo1.attach and within brackets type 3. Then put semicolon. This syntax means that we have attached the signal pin of the servo to the digital pin 3 of the Arduino. We have interfaced potentiometer to the analog pin A0 of the Arduino. Let's type coding for that. Type pin mode within brackets A0, input. Then put semicolon. Make sure that the letter M in pin mode and input is in capital letters. Then go to void loop and type value equal to analog read within brackets A0. Then put a semicolon where R is in capital letter in analog read. The analog value read by the pin A0 will be stored in the variable value. It's time for us to write syntax to check the condition. Type if within brackets value equal to 0. Then open a curly bracket. So if the value is equal to 0, then the servo should rotate by 0 degrees. Let's write the code for this if condition in the curly bracket. Type servo1.write within brackets 0. Then put a semicolon and close the curly bracket. The codes for this condition must be written within the curly bracket. We can add more conditions. For that, copy these codes and paste it below the curly bracket. Our second condition is, if the value of resistance in potentiometer is 164, then the servo should rotate by 30 degrees. So change the value from 0 to 164 and the angle of rotation from 0 to 30 degrees. Let's paste these codes again to add another condition. Our third condition is that if the value of resistance in potentiometer is 348, then the servo should rotate by 60 degrees. So change the value from 0 to 348 and the angle of rotation from 0 to 60 degrees. Paste these codes again to add the fourth condition. Our fourth condition is that if the value of resistance in potentiometer is 511, then the servo should rotate by 90 degrees. So change the value from 0 to 511 and the angle of rotation from 0 to 90 degrees. Paste these codes again to add the fifth condition. Our fifth condition is that if the value of resistance in potentiometer is 696, then the servo should rotate by 120 degrees. So change the value from 0 to 696 and the angle of rotation from 0 to 120 degrees. Let's paste it again and change the value from 0 to 859 and the angle of rotation from 0 to 150 degrees. Let's paste it again and change the value from 0 to 1023 and the angle of rotation from 0 to 180 degrees. The curly bracket at the end is the bracket for the white loop, inside which we wrote all the conditions to make the servo rotate. We have finished with our codes. Now let's see how it works. Click on Start Simulation and turn the potentiometer. Yes, we can see that the angle of rotation of the servo varies according to the resistance value of the potentiometer. When the value of resistance in the potentiometer is 0, the angle of rotation of servo is 0 degrees. Then as the value of resistance in the potentiometer is increased to 164, the angle of rotation of the servo is 30 degrees. When the value of resistance in potentiometer is 348, the angle of rotation of the servo is 60 degrees. When the value of resistance in potentiometer is increased to 511, the angle of rotation of the servo is 90 degrees. When the value of resistance in potentiometer is 696, the angle of rotation of the servo is 120 degrees. When the value of resistance in the potentiometer is 859, the angle of rotation of the servo is 150 degrees. Finally, when the value of resistance in potentiometer is increased to 1023, the angle of rotation of the servo is 180 degrees. See how beautifully the servo rotates according to the text codes we have entered. Now dear, stop the simulation. Now I hope you understand why servo motor is widely used in robotics, camera and many other applications. So we learned how to control the angle of the servo using potentiometer through block coding as well as text coding. The next session will be most interesting one because we are going to create something magical using the servo motor. Excited? But wait till the next session. Until we meet again, bye!